All right, part 3 of our Unit 4A practice test video. All right, we are on number 16, geometric sequence. Probably the easiest thing on this whole quiz, or at least I think so. You know, y'all have learned, don't ask Miss Gallen if she thinks something's easy. That's a bad idea. Okay, so we have a geometric sequence, and in order for a sequence to be geometric, there needs to be a common ratio between consecutive terms, which means I should be able to take this first term 2, multiply it by something to get 8, multiply 8 by that same thing to get 32, multiply it again to get 128. So I should be able to multiply each term by the same number to get this next term. So first thing we need to know is, what am I multiplying by? This is a pretty obvious one. It's a pretty easy one to figure out, but some of these are not as obvious. So in order to find your common ratio, you take 2 consecutive terms. So you have to either take terms 1 and 2, or 2 and 3, or 3 and 4. You can't take term 4 and term 2. That doesn't work. Take 2 consecutive terms and divide them, and that will give you your common ratio. So let's take our second and our first term and divide them. We've got 8 divided by 2. That gives us 4. So my common ratio is 4. All right, so then we need to write our explicit formula. And that is the formula that we use to find any given term. So the formula for the explicit formula is a sub n equals a sub 1 times r to the nth minus 1 power. Okay, so this is our formula for every geometric sequence. This is just like our template to make our formula from. If we want a formula for this specific sequence, we're going to fill in the first term, which in this case is 2, and our common ratio, which in this case was 4, and then we're going to leave the n's in there. So when it asks you, like, what is the explicit formula for this sequence? Or if it says, write the explicit formula, this is what it's looking for. I shouldn't see numbers in here for n. Now, I'm not telling you don't plug numbers in for n, but if I ask you what is the explicit formula, this is what I'm looking for. I should be able to take whatever term I want and plug it in. If you have a number in for here, then you're only giving me the formula for that term. You're not giving me the formula for the entire sequence. Okay, so now I want to use this formula to find the 8th term. So instead of n, I'm going to plug in 8. So this says the 8th term is equal to 2 times 4 to the 8 minus 1 power. Okay, 8 minus 1 is 7. So I am doing 2 times 4 to the 7th. And when I do that, let's see. I'm looking at my answer from when I did it in my previous video that just didn't happen to have any sound, which made me sad. Okay. So it is, all right, so when we multiply this, 2 times 4 to the 7th, we should get 32,768. Okay, and that should be our 8th term in the sequence. So if you were to keep multiplying and list all the terms out, this would be term number 8. Okay. All right, we'll go to number 17. So we're getting into exponential functions. Okay. So one of our big focuses on exponential functions, we talked about compound interest. Another popular, so compound interest is a popular modeling problem for exponential functions, and that's a popular way of looking at exponential growth. A very common popular way of looking at exponential decay is looking at depreciation, which is kind of the opposite. It's like when you buy something and then it's not worth as much. Anytime you buy a new car, it depreciates. So in number 17,